There's a lot of things out there that are designed to help you become a better programmer. You can buy somebody's course, you can watch YouTube videos, you can read books, you can read Wikipedia articles. There's a number of things that you can do to help you grow as a developer. The one thing that helped me tremendously later on in my career is learning functional programming. And it's taken me a while to begin to think more functionally, just because coming from a C sharp world, right? Everything is object oriented. You have your class, you have your properties on your class. They might be, private fields, getter, setter. You have your constructor, dependency injection. You might mutate data structures. Everything's in the object oriented style of programming. And functional programming is difficult to wrap your head around in the beginning just due to the difference of syntax, right? The closest thing that you get out of the box for functional programming in .NET is LINQ. And LINQ is basically a functional inspired set of features that allow you to communicate with data sources, chain methods together, and compose methods. And one example of this is the select many statement, which basically translates to bind in a functional programming language. And so, given that background, even though I was familiar with how to use LINQ and how to chain select where and two lists together, I wasn't really thinking functionally. I wasn't really thinking in the context of pure functions, composability, monads, functors, expressions. That just wasn't on my the front of my mind as I was programming. And the one thing that I noticed this change is I noticed I started to think about error handling a bit differently. And I started to think about generic types. I started to think about null, how to handle null references. I started to think about all these things, and functional programming for me seemed to be the solution, because one example that you're going to run into is you're going to have two methods in let's say, an object-oriented world. You're going to have one method that returns an int. You're going to have one method that returns a string. You're going to want to call those back to back. Now, you can set a variable to be the output. In an object-oriented world, you might pass it by reference, and you might modify that variable that you pass in. But you still have to get around the fact that they're different types. And so functional programming, at least for me, allowed me to start thinking about, okay, well, how can I wrap this, data inside of a common object? And so you basically work with lifted values, right? So if you have a common object and you pass it through your methods, that can allow you to chain your methods a little bit cleaner. So not only do you have to do any conversion, you don't have to write, a bunch of conditional statements within whatever your executing method is. You can just compose those methods together, whether it's bind, whether it's link to if you're working with propagator blocks in C sharp, whether you've created your own extension methods, whatever it is, however you choose to do that, establishing a common object to house your data. And so you have the same input as the same return. You have the same left and right identity. Allows you to string your code a little bit tighter, a little bit cleaner together. And that's never something that I really thought about in the forefront of my programming, especially not earlier on in my career, because earlier on I was too worried about honestly writing the perfect looking code, right? Writing the perfect object-oriented code. And object-oriented code does not really, I would say, it doesn't really promote the same values as functional programming does. And so you might be tempted, if you're coming from an object-oriented background, you might be tempted to want to modify a list. You might be tempted to want to, modify state outside of your method that might influence how the method operates. And both of those things are a direct violation of functional programming. Functional programming does its best, or to use pure functions, immutable data structures, and there's no modifying state outside of that scope of the function. And those things helped me to write a little bit cleaner code, but also a little bit more succinct code. And not succinct just purely from the perspective of writing less lines, succinct in terms of how you handle edge cases, try catches, retries, error handlings, fault propagation, logging, all this stuff. All this stuff, if you chain it together in a series of methods, for example, if you establish a propagator block, what you can do is you specify your target and your source block, whether it's a transform block, action block, broadcast block, whatever it is. You specify your blocks, and then within the blocks, because they're going to be primarily based on tasks, you can use tasks. What's built into tasks in .NET, you can basically register a callback to happen with those tasks. So in the middle of your flow, your data flowing through your pipeline, you can establish error handling. So if anything in that pipeline breaks, it'll be picked up by your callback and handled appropriately. But you don't have to do that, or basically you don't have to write all that logic for each certain, number of steps, right? Because if you ever find yourself working in I would say a heavy object-oriented programming paradigm, and you make any kind of external API calls that maybe you're using HTTP client, you're making some external call to somewhere, right? That you have to handle that error somehow. If it's an API, you have to handle it accordingly and return back an appropriate status code, whether it's you're going to throw an exception, whether it's you're going to basically log that error and then return manually that status code. If it's not an API and it's in the middle of some kind of running application, maybe it's like a front end or something like that, you're going to want to basically wrap that in some kind of error handling block, and that's probably most commonly going to be a try catch block with maybe if you get fancy, you're going to implement some kind of retry policy on that to happen. But the problem is it's only accounts for that individual HTTP client execution. You can set them globally, right? You can set custom or typed HTTP clients. You can set global retry policies. I'm aware of you can do all that stuff, whether it's in the middleware or a custom service. But the thing is that you still have to put a lot of that code in every executing spot of your clients and a lot of your object-oriented methods. And so what tends to happen is you get repeating code, you get a lot of kind of nested, code, and you get a lot of just kind of spaghetti code that kind of lingers around in a lot of your files. And that's not a fault of object-oriented. That's just a fault of what tends to happen the more we work in a system, the more we work in individual files. We just kind of add to the bloat of the file. Functional programming, I feel like, challenges that a little bit. It challenges you to think, how can we think about code as data? How can we think about code as a function that can be reused? And for me, when I write code that's composable, when I write code that maybe extension methods that can be chained together, when I think about my code in terms of that, not only does it make my code a lot more testable because it's individual units, but it allows me to think about what happens if one step in the sequence fails, because error handling is just kind of part of that paradigm. It's part of that style or practice of functional programming. And the same thing with logging too. Logging is really on the forefront of the thinking that is necessary for functional programming to truly happen, because let's face it, if you have an individual block that fails, right, and you want to either stop execution or log that part of the block, but then you want to continue, you have that common data object you're working with. So continuing is not going to be as much of an issue, maybe had you not been in that method chaining paradigm and you had to, let's say, break out of an if, make an empty object, and then drop down to another method or line. And so when you think about it like that, not only can you structure and set up logging in that style, but you can also establish, we can use the word circuit breaker, style, whatever you want to call it. But you can establish some kind of pattern a little bit easier with that. Another benefit I see is that when you want to inevitably come back and add features or code into your system, if you set it up functionally, it's going to be a lot easier to go and add some type of code right in the middle. Because let's face it, how many times have we worked on features or anything where the code necessary to make that happen is like right in the middle of like main core executing logic? That's just what happens with code, right? That's just sometimes the nature of the job. It's sometimes just unavoidable. But if you work in a functional environment, you can be sure of a couple things. You can be sure that the data in that list, is immutable. It's not going to be modified. There's no external state that's going to modify the flow of the system that's going to just throw me off, right? So we get these assurances that you don't get in object oriented, or that at least that you don't assume that you get. And so when we think about it, if we set it up in, let's say we're binding methods together, or we're chaining methods together, if we need to add a step in there, we can create that external, small block of code and put that in where we need to, and then just use our common data type to specify for the input and output. So it works a little bit cleaner, but setting it up that way takes a little bit of thought, right? It takes a little bit of, okay, let's stop and think about this, because if you don't stop and think about it, usually what tends to happen is you write, the traditional if condition, do this, else do that, which again is perfectly fine code, but sometimes we want more out of what we're working with. So sometimes, again, especially if you're working on the start of a project, maybe it's worth that extra time to think about something. And let's say, how can we structure this differently to get some more assurances to make the developer experience a little bit better? Because that's really the hardest thing, right? Is, we as developers, we have to work in these files all day, right? Why are we going to make something that we can't work in easy? Or when we bring on the next person, they're going to have a really difficult time getting up to speed because it's so tangled up and confusing, right? That doesn't help anybody out. And we all know that it takes a long time to work with somebody and get them up to speed and help them answer questions. That takes a lot of time. And sometimes that can be, a bit exhausting, especially if you after you do it a number of times, and it would be easier if we all take a little bit of time up front and actually think about the pattern that we're using to build this code, right? Because you can knock patterns however much you want to, but patterns are there for a reason, right? A lot of it is there for familiarity with code bases, right? Because if you go into an environment where the code just is, it's so unique that it's hard to read, it can be challenging. But I don't want to knock uniqueness. Uniqueness sometimes is necessary. But I'm saying for the main things that are like just common everyday tasks, adhering to some type of pattern might make it easier for you. Now, if you're doing just crazy stuff and you have to do just stuff that's never been done before, yeah, maybe a pattern doesn't fit your use case, right? Or maybe you just establish a new pattern with your team, and you document it, and then everyone just follows that pattern. And so obviously it's going to be up to you. It's going to be up to whatever team you happen to work on. But I just think having those conversations and being really open-minded about the ideas and possibilities is what's going to get you ahead. Because let's face it, if you work in an environment where there's no open creativity allowed or ideas are dismissed, that's a really difficult environment to work in. And that's not really conducive for writing, I would say not writing like good code, but also fun code, right? Because there's a difference of, just writing something to write it and, moving on to the next task, and you don't really have fun with it. That's going to lead you to burn out. At least that would for me, right? Just mindlessly, just kind of going through the motions and everything. If you want if you're looking for something more, maybe start researching design patterns and just see which ones you like, because there's a lot out there. One interesting one that I find helpful is railway oriented programming. That's more of a niche one compared to, maybe like, factory pattern or something like that. So there's a lot of them, like railway oriented programming, factory pattern, repository pattern. There's a whole bunch of them out there. Obviously, MVC is the big one. Maybe just figure out which one you like. You know what I mean? Like which design pattern kind of, you like the feel of, and just kind of stick with that and just go with that. So I think a lot of it is just experimentation and research and just discovering what it is you like. So that's all I got for today. Thank you all for watching. I'll see you in the next one.